We're going to sketch the basic function f of x equals the absolute value of x, and that is the v for victory graph, has a point at the origin 0, 0. Then we're going to graph two variations of that function. We're going to graph g of x equals 2 times the absolute value of x, and h of x equals 1/2 times the absolute value of x. It's a good idea to review video 74a before you look at this. So 2 times f of x is what we see with the g of x. Since f of x is being played by the absolute value of x, 2 times the absolute value of x, which is our g function, is 2 times the basic function f of x. And if you review video 74a, you'll see that that translates into a vertical stretch by a factor of the c number, which in this case is 2. So when we do the graph, it's going to look similar to the v picture, but it's going to be stretched vertically by a factor of 2. Now the h of x is 1/2 times the absolute value of x, so it's essentially h of x equals 1/2 times the basic function f of x. So now our c value is equal to 1/2, and according to video 74a, when you multiply the f of x basic function by a number c that's between 0 and 1, like 1/2, it manifests itself as a vertical compression of the basic graph by a factor of 1/2. Okay, so let's see what this actually looks like when we graph it. We have our y-axis and our x-axis. We're going to go ahead and graph the f function first. Now we're going to find a couple of ordered pairs. When x is equal to 1, f of x is equal to the absolute value of 1, so the ordered pair 1, 1. When x is equal to -1, y is equal to f of 1, which is +1. So we have the two ordered pairs, xy equals 1, 1, and xy equals -1, 1. And of course we have the point at the origin, 0, 0. Now to graph the other graphs, we just make the modifications recommended in video 74a. For instance, let's look at the h function. The h function, we're multiplying c times f of x, where c is 1/2. So according to video 74a, we're going to multiply the y coordinates in the original ordered pair of f of x by a factor of 1/2. Okay, so we take the ordered pair 1, 1, and we only modify the c coordinate by multiplying it by 1/2. And then take the other ordered pair, which was -1, 1, and multiply only the y coordinate, and we get -1, 1/2. Now connect the points together and look at our h function. We have a vertical squash, a vertical compression by a factor of 1/2. Now let's see how it's going to affect the graph when we do g, where we're multiplying the basic function by 2. Well, we're going to be multiplying the y coordinates in the basic function ordered pairs by 2, because c is equal to 2 here. So 1, 1 becomes 1, 2, -1, 1 becomes -1, 2. Now connect these together, and we have our g function. And sure enough, we have a vertical stretch of the original f function by a factor of 2.